All right, pre-calc. I am recording this as we are in class, so try this warm-up. There aren't going to be any built-in pauses here. Try this warm-up and go ahead and pause your screen now, try it, and then hit play when you're ready to see the answer. All right, so we've got our center, our vertices, and our co-vertices graphed. We know that this opens horizontally, so we should get something like that. And by the way, Michael asked me last night 27, I think, on the conics review. The key was totally wrong, right? It was opening the wrong way, so just keep that in mind. All right, so I've got some isometric graph paper here, and we are going to label this. This is now my x-axis, my positive y-axis, and my positive z-axis, okay? So let's start by plotting the point 1, 2, 3. So what I'm going to do is, not that, I am going to grab that purple dot and start at the origin. Okay, so I'm going to take it, we're going to have to do it this way. Start it right here. Okay, now watch where it goes. It's going to go 1 on the x. So there's 1. Now, look at this line here. That's parallel to the y-axis. Do you see that? It's now going to go 2 in that direction. So 2 in the y. So I'm going to go 1, 2, and then 3 in the z direction, which is going to be straight up. 1, 2, 3. Okay, so that is where that first point is. Now, so notice my next one starts with a negative. So let me start at the origin. So now it's going to go in the negative x direction too. That way. Does that make sense? So negative 2 for x. Now positive 1 for y. So that would be in this direction. And then up 4. 1, 2, 3, 4. So that would land right there. All right, this next one, this green, goodness. Okay, this green dot here, I'm going to start at the origin. We're going to go 3 on the positive x. Now negative 2. So again, really think about this y-axis. I'm going to go parallel to that, but backwards. So negative 2 and then up 5. 1, 2, 3, 4, 5. It's going to land right there. In terms of the room, we're going to have 3, and then we're going to go out and then up. Where would the dot be? Right in the hallway, right? Okay. All right, now this last one, 2, 0, negative 2. So positive 2 on the x. Now nothing on the y's, right? And now go straight down 2. Where would that land me in the room or in 3D space? Underneath that, exactly. Maybe right here. Okay, so let's take a look at a simulation here. So let's plot one of those points. We've got one that we did was, let's do the second one, negative 2, 1, 4. So negative 2, you see how it's moving there? 1, and then 4. 1, 2, 3, 4. Okay, and I can rotate this. So there's my dot as I rotate my 3D space. All right, how do we feel about that? Okay. All right. And go ahead and copy what I have. So distance formula in 2D and distance formula in 3D. If you are watching, go ahead and pause the screen and then hit play when you're ready to fill it in with me. Okay, so for distance formula in 2D, we take the square root and we subtract our two x values and square them, plus take the difference in our y values and square those, right? Basically, this is just Pythagorean theorem. Right? Formalized, essentially. That's your distance formula. We're just going to extend this same idea, but now we have a third variable called z. Okay? So really similar. We have a big square root. We're going to take the difference in the x's and square it, plus the difference in the y's and square, plus the difference in the z's and square. Okay, go ahead and copy the rest of the screen, pause, and then hit play when you're ready to fill it in with me. When we're taking a midpoint, you want to think about average, right? So in 2 dimensions, you're going to average your x values and average your y values to get right in the middle, the midpoint. So not surprisingly, for 3D, you're going to do the same thing. You're also going to have z. So average your x's, average your y's, and average your z's. Okay, so let's try this example together. It says plot the points 1, -2, 1, and 3, 0, -1, and then find the distance between them as well as their midpoint. Okay, so if you want to draw a new XYZ on your graph paper. All right, so this first one, we're going to go 1 on the x, and then -2, so now we're going to go backwards, and then up 1. So that's going to land me right there. The next one, 3, 0, -1, I'm going to go 3 on the x, then hold still, and then down 1, and it's going to take me there. Now here's the most common mistake I see, is students will say, oh, here, their distance is 1, 2, 3, 4. Why is that usually wrong? I mean, you could get lucky and get it right, but what's wrong with that idea there? You're not considering that third dimension, right? You just stacked these 2 points on top of each other. So be really careful that the plotting doesn't throw you off, okay? So let's find the distance. So the distance formula, big square root. So let's find the difference in the x's. So I'm going to go 3 minus 1 squared plus 0 minus -2, so plus 2 squared, plus, now subtract your z's, -1 minus 1 squared. Okay, so here I've got 2 squared, so 4, plus another 2 squared, plus another, basically 2 squared, right? Do you like square root of 12? Yeah? And we can simplify as 2 square roots of 3 if you'd like. Just make sure you read on my math lab how they want it. Okay, and then if I want to find the midpoint, what do I do with x, y's, and z's? Average them. Okay, so the average of 1 and 3 is 2. The average of -2 and 0 is, what's right in between -2 and 0? -1. And then the average of 1, what's right in between 1 and -1? There we go, that's it. Now, if I plot that point, 2, -1, 0, it looks good. Do you agree with that? Go ahead and copy my screen, pause and copy my screen, and then hit play when you are ready to fill it in. All right, so a circle with center HK and radius R, if you remember, was x minus h quantity squared plus y minus k quantity squared equals r squared. Now, the analogous from circle to sphere would be 2D to 3D, right? So a sphere, let's say with center HKL, because now I need a z coordinate for the center as well, not surprisingly, is x minus h squared plus y minus k squared plus z minus l squared equals r squared. Okay, so you try the example, and then let's see how you did.
I don't know if you can see it, but we should have gotten x minus 2 quantity squared plus y squared plus z plus 3 quantity squared equals 49. Can we buy that? How would I make the radius smaller? I changed 49, right? Look at that. Now it's got a radius of 2. We see, let me get this centered the way we're used to. So there we go, right? 2, 0, negative 3. There it is. So there's our center and our sphere. Again, over 49, there's my radius of 7. Notice what happens when I have if you go from, like, if we're thinking conic sections, if you go from having both the terms squared to just one term squared, what shape do you get? Instead of a circle, you have a parabola, right? So if I don't have z squared, so if you go up to calc 3, you'll deal with these types of things. But in calc 1 and 2, we stick with 2 dimensions.
Okay, so we should have gotten there x minus 2 quantity squared plus y squared plus z plus 3 quantity squared equals 49. Okay. Let's try this last example. It says find all intercepts and then sketch a graph of the equation. So the way I like to do this is I just like to go x and then y then z. So if I want the x-intercept, like if I'm thinking two-dimensionally, then y has to be 0. Do you agree with that? So now both y and z have to be 0. So if we do this very properly, I would get 3x plus 2 times 0 plus 2 times 0 equals 9. But we can do this pretty fast because those are ultimately going to go away, right? So what is your x-intercept? Yeah. So my x-intercept is 3. Let's do the same thing for the y's. Again, basically the x's and the z's are going to go away. Do you agree with that? So I end up just getting 2y equals 9. So what would y be here? Yeah, 9 over 2, 4.5, however you want to think of it. So 1, 2, 3, 4. There's my y-intercept. For z, again, take off the x and the y, so you get 2z equals 9. In other words, your z-intercept is the same as that same 4.5. So up here, and what this is going to create, instead of a line, what do you think this is going to create, actually?
So here it is in 3D plotted. Yeah, it's called a plane. So the red here is your x-axis, and the green is your y, so I'm trying to get a good view for you. So it cuts the positive and the negative, sorry, the positive axes, all three. So if I were to plot it in this room, it would sit. So that is what we have there. Now, I want to show you what this looks like on my math lab, because to me it is
not very intuitive at all. So this is what it looks like on my math lab. These are your options. And the first year, a couple of years ago, is when I started doing my math lab, and I worked through them, and I was like, what? What is the right answer? Any idea? Yes, with the same problem. Assume that same equation. And so it asks you for the intercepts. We got those, right? Then it asks you which of these is the correct graph. It is B. Do we have any logic to that? So look at where the dark pieces of the axes start to appear, okay? So our intercepts were all positive, right? So see how you've got dotted pieces and solid pieces? Your solid piece should start on +3, +4.5, +4.5, and then come out, okay? The other ones, like here, I can tell that the y is negative. Same thing here and here, we've got those problems as well. So that's what it'll look like on my math lab. Let me know if you have issues.